Hello students, welcome you all. So now we are going to discuss theorem 10.8. The angle subtended by an arc at the center is double the angle subtended by it at any point of the remaining part of the circle. So what we have to prove here? We have to prove here that there is a circle in which PQ, this is an arc, and it is subtending an angle at the center POQ, and the same arc is subtending another angle at point A, that is PAQ. We have to prove that angle POQ is equal to 2 times angle PAQ. This is what we have to prove. Okay, this figure has some other variants like this. You can take this arc as a minor arc, or we can take this arc as an arc of a semicircle. Okay, then another condition may arise. You can take the same arc as a major arc. Okay, so now we'll discuss all the three conditions. So we'll start with the first condition. Okay, let's start. So first we'll start with a construction. So what is construction? Just join OA, AO, we can say join AO and extend up to it, up to B. Join AO and extend up to B. Then we'll move to the proof section. Now in the proof section, first we'll take a triangle AOP. In this triangle, this angle POB will be equal to, POB is an exterior angle, POB angle will be equal to sum of the interior opposite angle. So who are the interior opposite angle? This angle and this angle. You can write angle OPA plus angle OAP. Okay, but this triangle is an isosceles triangle. You can write OA is equal to OP, but OA equals OP. So these two angles will be equal. Angle OPA plus, not plus, equals to, this angle will be equal to angle OAP. OPA will be equal to OAP. Now this statement will be like, we need this angle OAP. So instead of OPA we can write OAP. So we can write, so angle POB, we are just writing this statement again. Angle POB will be equal to, instead of angle OPA we can write this angle OAP plus OAP, will write as it is OAP. So it will be equal to 2 into angle OAP. Write it as statement 1. Okay, now we'll move to this part. Similarly, angle QOB we can write, angle QOB will be equal to sum of these two angles. Write them OQA angle OQA plus angle OAQ. Okay, now which will be equal to, same as OA equal to OQ, we have written similarly, so we don't need to write it again. Okay, so OA equal to OQ, therefore these two angles must be equal. So it will be equal to, instead of OQA we will write OAQ. OQA के जगह पे हम लिखेंगे OAQ plus angle OAQ implies angle QOB will be equal to 2 into angle OAQ. Write it as statement 2. Now add statement 1 and 2. Adding statement 1 and statement 2. What we will get? First add LHS and LHS. Angle POB, this angle plus angle QOB. So we will get this angle. Just write angle POB plus angle QOB will be equal to, here RHS is 2 into angle OAP plus 2 into, here RHS is angle OAQ, implies, now sum of these two angles POB and QOB. Look at the figure. POB and QOB equal to POQ. Angle POQ will be equal to, here 2, we can take 2 common, 2 into OAP plus angle OAQ. Okay, implies, just write as it is, angle POQ is equal to 2 into OAP plus OAQ. Look at the figure. OAP, this angle, plus OAQ, this angle, will be the angle A or angle AO, we can say. So 2 into angle PAO. This is what we needed to prove. Okay, so hence you can write proved. Now we have proved that angle POQ is equal to 2 into angle PAQ. Now we can move to the next figure. Okay, to this figure. Here the proof will be also be the same. Okay, just look at the figure. I will clear it out a little bit. Okay, now you see, come to this figure. In this figure, one second. Here same, this angle will be equal to sum of these two angles, and these two angles will be equal. Okay, here also same, this angle is equal to sum of these two angles. Okay, and you will add these two angles, then you will get angle POQ. POQ will be equal to 2 into angle PAQ. Okay, so it will be proved in the same manner. Okay, then here also come you can see this angle POB is equal to, here the exterior angle, opposite exterior angles are this angle. Okay, and this angle. Okay, here also same, angle QOB or BOQ, you can say, is equal to sum of these two angles QAO or OAQ, you can say, plus angle OQA. Then these two angles will be equal. Here also these two angles are equal, so that it will be proved in this same manner. Okay, and the writing will also be same. So you can write similarly the second case and third case can also be proved. Okay, now we don't need to prove the second case and third case separately. So this is the proof of this theorem.